Hi everyone, I'd just like to give you all a very warm welcome to today's webinar and actually just extend my thanks and gratitude for your time this afternoon, this morning, wherever you are in the world. I appreciate for some of you listening, this is a little later on in the day for you. Some of you, this is first thing in the morning. So from wherever you are listening, a massive thank you from all of us here. Hopefully you can extract something useful from this, something positive in exchange for your time. So my name is Josh Fulford. I work in a fantastic global team here at Not So Secure. I've been privileged enough to be working here for around about 2.5 years now. Now, today we're going to be giving you a brief run through around cloud storage and the security aspects that you could and should probably be aware of from both an offensive but defensive perspective. This is applicable to hopefully all of you listening, regardless of your prior technical understanding. I mentioned briefly, and I say brief, a brief run through, as this webinar will give you a good hour's taster of one of our most popular courses, which is tailored specifically around cloud security. Obviously, as a disclaimer, this isn't going to be the full course. But to take you through this, I will very shortly be handing you over to one of our most senior trainers, Anthony Webb. But first, if you don't mind, I'm just going to quickly give you a very quick introduction to who we are, what we do, and hopefully why it actually will positively affect you. So moving forward, answering the question of what we do then. So quite simplistically, as you can see in front of you there, we hack, we teach. You could also probably add on the fact that we protect as well. I'll probably touch upon this a little later on. Now, on the left-hand side there are not all, but just some of our ethical penetration testing services that I'm sure many of you, if not all of you on the call today, will be familiar with. So as I mentioned on the left hand side, web application and infrastructure assessments. Well, for us from a testing perspective, what is that? Well, that is simply what is accessible from an external point of view. If this application was a ship, what is tied down, what isn't tied down, what's been secured properly. For your network, if an outsider can access your externally facing assets, then what privileges can they escalate? And then moving forward down the list progressively to some of the other services there as well. In terms of source code reviews, are all your applications secure by design? For red teaming at the bottom there, if we simulate a real life threat or impose a real-time attack, how far can we get? How reactive and how proactive are the blue team in this? And why is all that important, you may ask? Well, securing your data and information through your applications and physical assets, that's going to help you maintain your reputation and consumer trust. But also the return on investment actually is more of an invisible one, whereby being proactive and, for example, spending 20 grand on a pen test or a training requirement instead of 500 grand in ransom is going to be a significantly cheaper option in the long run. Now, one thing I didn't mention, while securing your data properly is absolutely pivotal and absolutely vital, the biggest threat to an organization is the human element, right? Why spend hours trying to gain access when by just asking someone and saying the right things at the right time is inevitably going to get you there much quicker. In my opinion, this is where we really come into our own with our offensive and defensive cyber training portfolio. As you can see there on the right hand side, this really ranges from an entry beginner level right the way through to a more advanced level. And these courses cover an offensive perspective. So this is your ethical testers and really anyone wanting to learn or actually enhance this skill set. But actually, it's also for some for professionals who work on the defensive side of the fence on a daily basis. We're trying to stop the bad guys. Now, quickly, it's just important to mention, I guess, that like I said earlier, we also have a managed services offering, so the protection side of things. That will actually proactively look at and manage your security posture. Why is this good? Well, we simply just become an extension of your security team. Hopefully this will save you time. Hopefully this will save you money. The classic phrase, time equals money, right? We are officially part of the Clarinet Group, as you can see in the middle there with the banner. So hereby you would have probably most actually infamously known or heard of our name or come across our logo from our training and exhibiting our globally renowned Black Hat conferences, the most recent of which in 2019 I was fortunate enough myself to attend, where we trained between 500 to 600 people. Progressively moving forward, in 2021 we were due to hugely exceed that number, but obviously due to COVID, that's been ramped down ever so slightly and scaled back. Moving forward in the future, hopefully we can get back to increasing those numbers moving forward. So just lastly, to wrap up on my end, I've spoken about who we are, what we do, but we truly differentiate ourselves through our flexibility, and not many companies offer the speed we do. Many companies say they do this, but really in comparison to us, I don't really think they do. With this, we appreciate that you may want security with speed and scale. So we're very accommodating for all types of customers, no matter what category you fall into this. With that, we offer competitive testing rates to allow you to hopefully reinvest into your security infrastructure and security controls. Affordability, I guess, is a big buzzword with that. But actually, there's a lot of consultancy work that we do for free. Well, why is that? Well, we just want to help you on your security journey. But with all of that I've said, actually, probably the most important aspect is the teaching side of it. We teach individuals and companies, organisations, how they can be more secure and compliant. That's a massive thing, certainly today in an ever-changing world. Just moving forward one slide, we've also got a free training prize draw. This will be for the hacking and securing cloud infrastructure, as I mentioned a little bit earlier. It's available on a 2-day or a 4-day platform, subject to your preference. All you need to do to be in chance with winning this is just speak to us about a potential training or pen test requirement. However big, small, whatever it might be, you can get yourself entered in that competition and a chance to win. The email address on the slide before is training@notsosecure, but actually, if you just want to submit a web inquiry, just reference the webinar with further details, and you will be entered. So without further ado, I'll hand over to Ant, who will take you through cloud storage security.
Thanks, Josh. Right, my turn. So yeah, welcome and thank you and all of that stuff that Josh just said. So my name's Anthony. I am an associate director here. I've been training with NSS now for 4 or so years, but I've been officially a security guy for probably 6 to 7 years now, corporate, and then, you know, a geek forever. So in that time, I've spoken and trained at all sorts of events. As Josh mentioned, we're at all the Black Hat events, and I've done almost every single one globally, including all of their little training events for the last 4 years, the exception of maybe 2. Bunch of other events as well. I do classroom training, in-house training, and all of that kind of stuff. So I've been doing this for a little while. I am also a pen tester. Like Josh said, we hack and we teach, and that is exactly what I do. The idea being that I actually take the real experience from the pen testing and then I bring that into the course. None of the labs that we put together are contrived in any way. It is all genuinely stuff that we've seen on our tests, and you will see, even in fact, during building this webinar, one of my colleagues ended up discovering quite a serious vulnerability, which we ended up having to negotiate and resolve before we could publish this webinar. So you'll see exactly the sort of thing I'm talking about. As a pen tester, you kind of can't help but pick up letters, but as I say, I would rather just tell you I've been a geek forever. I started coding on a BBC Micro, if anyone is old enough to remember those, way back in the early 90s. Obligatory Twitter handle, you probably don't care. I'm not a prolific tweeter or anything, but if you do ever want to talk shop, I'm always willing. It's as good a place as any to reach me. With all that said, you don't really care about me. You are here for the content, so let's get to it. The goal of this webinar is to cover it is a fraction of what is worth knowing about one service amongst the 200 odd services that exist within each cloud provider's portfolio. So we are talking about cloud storage alone, by which we're talking about, you know, AWS S3, Azure and GCP call it containers, storage containers. That is the one service we're talking about, and we're going to look at a few interesting scenarios around those. So there is a world more to explore, but I've got what, 45 minutes to get this through, so I'm going to talk quite quickly. So we're first going to explore what makes it storage, object storage specifically, and how that differentiates from, for example, block storage, which is what we traditionally have always used in computing. What that means the attack surface is. We'll have a look at some interesting threats that we saw in 2021 that were sort of quite new, really. In particular, ransomware moving from being a very much in-network thing to it being a cloud-native thing. And we'll look at the Magecart attack, which some of you may already be familiar with, but it's a very, very interesting attack. Huge supply chain attack, compromising obscene numbers of machines and doing untold damage, really quite complicated, but actually all built around one very, very simple vulnerability, which was very easy to exploit. We'll look at some of the misconfigurations that can lead to these kinds of attacks taking place, and how we can abuse these en masse. And we'll even give you some advice on defense, which I'm going to be totally open with you. I am an attacker, I am not a defender. So it's always a little bit uncomfortable for me when I start trying to talk about how to actually lock your doors down rather than open them up. So all of the big three cloud providers and the majority of other cloud providers that exist offer some sort of object storage solution. So as I say, AWS call it S3, which stands for Simple Storage Solution or Simple Storage Service, one of the two. But the reality is it's actually not that simple. The thing that makes it awesome, I suppose, is it's got incredibly high uptime because it's effectively distributed storage. So block storage, as we're familiar with, we're talking about sort of well, historically magnetic disks moving on to SSDs and so on, but block storage was very much you would have a drive and it would have data stored on that drive, whereas with object storage, we're uploading objects into the sort of the abyss that is the cloud. You send these objects up and they're put somewhere, and you don't really worry too much about where really. You upload the object, it might be a file, it might be a simple piece of data. You can upload some metadata, that's effectively data that describes the data. So, you know, how big is it? What is it? Is it an image? What's it an image of? All of that kind of stuff. You can define other attributes and other properties for each object. You can define the permissions associated with that object and stuff like that. Because it is distributed and basically like sending data into the abyss, it's also pretty much infinitely scalable. There have been the occasional scenario where someone has managed to actually exhaust a cloud provider's resources, but it's a pretty rare thing to happen. Generally speaking, you don't need to worry about scale. You can just dump data and it will be there, and you can retrieve it when you want it using the references that you're given for those objects. What makes it fundamentally different then to block storage is it's not structured. So it is completely decoupled from your other services. The data, the objects, as I say, is just sort of effectively floating around in the abyss. You don't need to know where it is or how it's physically stored. Whereas with block storage, it will be on a disk somewhere. There will be the location of that record. Each record will be indexed, which makes block storage much more appropriate for things like databases, where we're using data at scale and we want to be able to retrieve it very, very quickly. Object storage is still very, very fast, but it couldn't be as fast as block storage in those kinds of scenarios. So it's kind of aces in their places, but block storage ideal for databases and large applications, very, very large applications handling large amounts of data that's sort of structured and organized. Object storage much, much better for unrelated data and for decoupling. And that is pretty much the main aim of cloud computing. It is to loosely couple your solutions. So instead of having a device that is an application server and has various other resources running on it, various other servers, maybe a database or whatever, you can completely separate this stuff. So you have a service running your application and it interacts with some other service which holds your data, which holds these objects, some other service that handles some other portion of what the application as a whole does. And these things are all distinct, they're separate, they're not coupled together tightly on a single device. So this makes object and block storage at the core of pretty much any cloud solution. You absolutely can use block storage within cloud, but object storage is ideal for an awful lot of scenarios. And permissions on these objects are actually incredibly straightforward. However, that does not mean that everyone is doing it right. And we do very often find that data has been put into this abyss, which it is intended to be somewhat private, somewhat confidential, and actually you can find it just by looking in the right places. So there are two main ways that we would go about gaining access to your data if it's in the cloud. I'm going to start off with indirect attacks, which might seem a bit illogical for me to go in this direction, but it hopefully makes sense in a minute. Here we are talking about where you attack the data storage via some other platform, some other application. So generally speaking, if you're using data storage to hold objects related to a web application or some other application. The application is going to be internet facing and is also going to interact with that data storage, that object storage in the back end. We're going to work on the assumption that you've got the permissions correctly assigned on the actual object storage itself. I wouldn't be able to just go and interact with the object storage service, S3 or whatever, and just say, hey, show me the data, and it'll go, hey, here you go, here's the data. I'm going to assume that you've locked that data down, but your application needs to be able to access it. And if I can compromise the application, then via that application, I can then access the data. So this is where we're basically abusing IAM permissions, identity and access management permissions that are associated with the application itself in order to give us access to the data. So we'll give you a quick example. It's a bit of a weird one. We've got an account signed in using the AWS command line tools on this machine here. So we're just going to run a command called get caller identity, which just shows you that I'm running as the root user in this user account, which is just unrelated to our victim that we're attacking. And I'm going to attempt to retrieve a directory listing for an S3 bucket called victim private. And we're going to get an access denied error. We are not allowed to interact with that victim private bucket because it is locked down. It is set to private only access. And we're not even allowed to query the access control list for this bucket because it's not ours. It's completely private. We're prying into something that we've got no right to access. So we just wanted to make sure you could see that right now from this user, I'm not allowed to interact with that bucket. But we found this bucket because it is actually in use with this application here, which is called voffice.victim.cloud. It's got a login prompt. And this is effectively the application that we're pen testing in this sort of made up scenario. And if we look at the source for that single login page, it turns out it pulls in a bunch of JavaScript. And if we take a look at the one called config.js, you can see that there's a mention of Cognito. Cognito is an identity service that AWS operate for application accounts. Oh, that gets slightly too far ahead. Go back. Oh, I totally messed it up. Where is it? Go forward. Okay, so Cognito is an identity service that AWS run for us to manage identities for application users. So as the user of this application, I am authenticated via the AWS Cognito service, which will give me effectively a set of temporary credentials. And we can see that it's been set up in config.js in a second. Here we go. And these are the identities that are required in order to either register or anonymously access these credentials. So we need a user pool ID, a client ID, an identity pool ID. So what we're going to do is we're going to attempt to configure the Cognito service by taking those tokens, which are that they have to be hard-coded into the application, therefore pretty much have to be accessible to us. So we're going to interact with AWS Cognito, and we're going to do an IDP, which I can't remember what IDP stands for, identity pool, something like that. And we do a sign up to this client ID. And on this occasion, sign up has actually been disabled for this account. I'm just going to put in a made up username, give it a password. We're attempting to register a user. And the only reason we've done this is just to demonstrate. Mistyped it the first time, needed to put a 2 in. Just to demonstrate that not authorized, the sign up is not permitted for this user pool. And what that tells us is that in order to use this, we're going to need to do a anonymous sign in instead. So we're going to switch approach, and we're going to do, getting slightly ahead of my typing, a Cognito identity and then it's called get ID. We're just going to retrieve the temporary ID that's associated with that identity pool ID that we've just found on the site. I remember this going much quicker. So we need to pull the identity pool ID from here, and we'll paste that in. need to put the region in. It's one of my favorite things to forget with AWS, always missing a region off commands. And you can now see it's given us back an identity ID, which is different to this one. That's the hard-coded one. This is our temporary one that we've now gained access to, which allows us to do a cognito identity get credentials. So we do a get credentials for identity, and we feed it this ID that we've just retrieved. You can see it's an identity ID rather than an identity pool ID. It's a subtle difference that's very easy to mess up. Remember the region this time. And now we get back, and hopefully these might be familiar if you've ever interacted with AWS, we get an access key ID, a secret access key, and a session token. And those three pieces of information are what we need in order to configure that IAM account locally. So we can now just borrow those. And although we can't use AWS configure, which is how you would normally sign into a user account, you can't do that because that will only ask for the access key and the secret key, and we also need to provide the session token. So instead, we send those as environment variables using the export command, and we can just do it like this: export AWS access key ID, and we feed it the figure. Or I can actually save a little bit of time by using some slightly hacky one-liners that will grab this data, reformat it, and feed it to my environment variables for me. I'm incredibly lazy, so that's going to be my approach. So we're just running the same request. We're literally running that same request, but then we're using pipes to feed it into some tools called JQ, reformat it a little bit, so that access key ID becomes AWS access key ID in the correct format for the session tokens, for the environment variables. And then we use a bit of Perl as well, just to refactor the output. And so it will look like this. And then we can export those by doing the same thing and just piping it into yet another command. Just use a quick for loop for each one of those that is retrieved. We're going to export them. This doesn't give us any output, because we've now hidden it behind the export command. But if we now run sts get caller identity, we'll get a different response to what we had earlier, because we've now configured the Cognito Cloud HD identity pool unauth role. And using that, we can now interact with anything that that role can interact with. In this case, it can interact with that victim private bucket, and we can now do a file listing and even copy down files from it. And in here, you will find one of the flags from our course. As you can see, it should only be accessible to authenticated users, and that now counts as us because we've stolen that identity. The other form of attack is a direct attack. This is where we are going to directly interact with the storage service. So instead of gaining access through the permissions associated with a vulnerable application, we're going to directly mess with your storage service itself. And generally speaking, this is possible thanks to misconfigurations of bucket permissions. So first, we need to find misconfigured buckets. Fortunately for us, there are a number of ways of finding these. You've got search engines. We can literally go on Google, type in the site format for a S3 bucket, for example, type in the name of your organization, and we can see if any of those have been searchable by search engines. If they are, that already tells me that they were publicly accessible, because that's the only way the search engine could have spidered them. This will return, to be honest, a terrifying number of buckets straight away. You can find all sorts of sensitive data exposed to openly searchable buckets that clearly should not be. And there have been over the years hundreds, thousands of these things exposed and reported. Sometimes you might find buckets through application references. So within the application, you might find that it mentions a bucket, or maybe by downloading the application and pulling apart the source code, we find the mention of a bucket. So that might be how we discover storage containers, or finally just by performing a dictionary attack. So effectively just taking some keyword, maybe the name of your organization, maybe the name of the application, the name of the project, whatever, and then mixing that up with a dictionary of common terms that you might find associated. For example, is there a bucket named your org assets? Really common to find those. And effectively then it's just a brute force. We just go through all of the dictionary, all of the likely terms, fuzz them together with your company name or project name or whatever, and see what comes up. So there's a search engine that can help us with this. It's a search engine specifically for open buckets. It's called Grey Hat Warfare, and you can just browse to their site, type in some filter terms, and it has already pre-indexed all of the public buckets that it can find. If you pay for an enterprise level account, you can actually use some more advanced terms, and you could, for example, search for the regular expression that will return any bucket with credit card numbers in or something like that. And again, you will find a terrifying number of buckets that have that kind of data in them. So here is that in action. We've just searched for the term password, and you can see that as a standard user, we get 11 results of containers that have the word password inside them, but premium users could see 180 additional results, and you can see why they were excluded from your standard search. Or you can go the at en masse effort, and we can use a tool which will actually perform service mapping at scale. So what we've done here is I've just retrieved, there is a list on Amazon's site, and both the other GCP and Azure both do this as well. You can retrieve a list of all of the IP ranges that they own, all the IP ranges associated with AWS in this case. So we've downloaded that file. You can see it's a reasonable size file. It must have quite a few entries on it. And then using that data, which looks like this, it's a whole bunch of JSON entries, each one noting an IP prefix with a region and a service and stuff like that. Now on this occasion, we're actually not looking for buckets with this one. This was a sort of a separate effort actually that made sense to include. We're actually looking for EC2 instances here, but you can search for anything. There's no specific reason to limit yourself to EC2. So we're looking for any of these prefixes that contain the term EC2, and then we're just going to list out the top of those. So we can see that we've got a couple here, we've got the region, and they all relate to an EC2 service. I'm now going to do the same thing, but I'm going to tell it to only tell me the IP prefix. So now we've just got a list here of IP prefixes that are associated with AWS EC2 instances. I'm going to go a step forward and a step further and show the region as well. And the reason I'm doing that is because I'm going to want to exclude some of these regions. So right now I've just got a list of IP prefixes with their regions, and the one I want to exclude is US-gov. Hopefully the reason I'm excluding that is obvious enough. I don't want to go searching those. I don't want to get myself into any trouble. So we're just going to run that original command, looking for all of the IP prefixes that are associated with EC2 in all of the regions, with the exception of US-gov. And there was US-gov East and US-gov West, I believe. So there we go. We've now got a full list of all of the IP addresses relating to EC2 across all regions except US-gov. And just to confirm that, I'm just going to quickly check, and the US-gov term doesn't show up. So I think I've got that right. And now we're going to use a tool called ZMap. You've probably heard of Nmap. If you haven't, it's kind of the de facto network scanner and mapper. ZMap is kind of like its stripped down little brother, but it's really quick. So it can't do as much cool stuff, but for our purposes, it's going to give us a very quick scan. And just to show you what that might look like, we're doing a quick scan of port 80 on this one IP address and just seeing what happens. We can see that we're able to interact with it. And then we're going to feed the output into a tool called zgrab. and we're going to tell zgrab to interactive HTTP. And this is very much, we're building a tool by just feeding one output into another. So it is not an efficient way of doing things, but it gets us the output we want. So we're then going to feed that into AWS HTTP banners to give us a list of all of the banners from each of those IP addresses in that list. Now this takes quite a while. But the end result is we've got some output which we can then format and flatten, and we end up with a list of IP addresses with the HTTP banner that was returned after we messed with them. We're now going to search for the specific format that we're looking for. So S3 does have a number of different endpoint formats, but we are only looking for this one type just to narrow our responses down a little bit. There are quite a few of those with duplicates, so we then sort for unique. And then for each one of those, we are going to check permissions. And we're going to check first, are we allowed to do a directory listing on them? That's the straightforward thing to do. See if we can list out all of the contents of each of those buckets. And there is a reason that we focused on this particularly short list. And you can see we mostly get access denied. We're not allowed to do listings, but there are a couple that drop out some information. Some of that information certainly looks a little bit personal, like maybe we shouldn't be showing it. We can actually add recursive to this so that as it checks them, it will actually look not just at the initial sort of first listing, but it'll actually go through all of the subdirectories effectively. And there's an awful lot of stuff coming out of this. Someone's wedding. And we're just going to focus in on one specific one that caught our eye. And it's a service called Nova Music. It's kind of like Spotify. I think it's a sort of quite a regional, sort of Africa-based Spotify-like platform. And it turned out that if you browsed inside it, all of their MP3 files were publicly accessible. You could just go in and download them without a subscription. So we are able to show you this because as a result of building this webinar, of performing this enumeration, we actually ended up getting in touch with them, letting them know about the issue, saving them from some severe embarrassment. This is sort of company ending kind of stuff, to be honest. Any artist that had their audio listed on Nova Music was effectively, their music was now being listed for free for anyone who wanted it. So they've resolved it now. This bucket is now locked down. You won't find this and be able to access it. But we thought it was absolutely fantastic that just in the course of just building this to show you the process, we actually found a vulnerability, reported it, and got it resolved. And we were able to show you that as part of this. Something strange has happened. I got too far ahead. There we go. So let's talk about some other interesting threats that have been seen. There was a really major attack in 2019 through an application called MageCart. Effectively, a card skimming syndicate got access, and it was a supply chain attack basically. So MageCart was in use across all sorts of other sites that you trust, sites that you use frequently, sort of e-commerce sites. But it all came down to a misconfigured S3 storage container, which the attackers were able to gain write access to. They were able to insert malicious elements into some existing JavaScript that was stored on this S3 container, and that indirectly compromised around 17,000 domains, some of which were Alexa Top 2000 kind of popularity. We're not talking small e-commerce sites. We're not talking random ones that you wouldn't necessarily trust. We're talking pretty major suppliers were using Magecart, and because of this supply chain type attack, all of these victims were relying on that object storage to deliver resources to their users, to their end users, and because that storage was writable by attackers, they were able to put card skimming software, card skimming code into all of these 17,000 domains checkout process. So really, really serious attack, but as a result of the simplest possible misconfiguration. So the key vulnerability was literally just the buckets that were writable with scripts in them. Those scripts being relied upon by all of the sites that used Magecart. Once delivered, they would be they would pass the victim through to redirects, malvertising, whatever, and the final payload was there to skim their credit card details during the checkout process. The other contemporary threat we want to talk about was cloud native ransomware. So we're probably all familiar by this point. Many of us have probably encountered ransomware in the wild. It's effectively malware that spreads within your network and encrypts your data and demands a ransom to decrypt it. And they can be very, very clever. They can encrypt your data really quickly, because in fact you don't need to encrypt the whole file. You only need to encrypt the sort of initial part of the file that defines what it is and how you interact with it, and it makes the file useless. So by encrypting that tiny part of each file, it can very quickly go through and encrypt massive numbers of files, or at least render them inaccessible very, very quickly. But in fact, using a Rhino Labs proof of concept, they were able to demonstrate that you can completely encrypt 2,000 objects over 100 gigs of data in 1 minute 47 seconds. So really, really serious. Now, of course, interacting with data in the cloud is very, very different. And when let's skip how it happens for a minute, but if someone managed to get ransomware into your cloud environment and started interacting with your cloud storage, every single read write to your cloud storage is an action that's sort of loggable. So that kind of activity, reading in every file in your storage, overwriting every file in your storage, you would think that that would definitely show up on alerts. You'd log that straight away and you'd be able to stop it. And yeah, it's true. CloudWatch, for example, in AWS will certainly pick up all of that activity. The trouble is it takes around 5 minutes, thanks to the various API delays, before you would get that alert. If it can encrypt 1,000 gigs in 1 minute 47 seconds, 5 minutes is just a little bit too long. Your data's gone. You know about it straight away, but your data's already long gone. So how on earth can we go from the sort of traditional model of gaining access to a system and encrypting data on those block storage drives through to performing that kind of encryption on object storage, which requires a whole different way of interacting? We're going to compare here cloud native ransomware to traditional ransomware. So in traditional ransomware, the initial access is generally through some sort of exposed service. So for example, Eternal Blue, which is the basis for WannaCry, that's spread through a flaw in sort of SMB and RDP and sort of those kind of services that are generally exposed on a workstation. With cloud, we're going to be using VPC NAT. That's generally going to be our entry point. We're then going to expose some sort of service. With traditional ransomware, we'd be looking at interacting with vCPU. Over here, we're going to look at some EC2 instance. We then would traditionally gain access to a service account associated with some service in order to give us writable access to the file system. Those are IAM roles in cloud. If we can extract IAM roles, we can potentially perform functions using those roles, just like we just did when we used Cognito and we gained access to a role and we were then able to read that private bucket, those kinds of things. Then the really clever bit, with traditional ransomware, there'd be the file encrypting payload. We would go in and we'd have a key effectively and a process for encrypting. In cloud, we can actually abuse a service called the key management service. We can actually use its built-in processes that are intended for legitimate encryption of your files. We can share a key from the attacker's AWS account and then retrieve it into our victim's account and use that using the key management service, using the built-in encryption capabilities to go and interact with S3 in this example, to go and encrypt all of your files. So we're basically looking at abusing overly permissive IAM profiles, or IAM profiles that we're able to extract from vulnerable applications. An abuse of existing permissions leads us to be able to escalate to a position where we can get write access. So the only things we really need, we need write access to S3, and we can't do this, or we can't necessarily cause as much chaos as we might like if object versioning is enabled and or if MFA delete is enabled. So object versioning allows us to modify objects, and if you've got previous versions stored, then theoretically you could recover your data immediately. So if I go in and I modify your objects, you could just roll back to the previous revision before my encryption. So that's one potential caveat. The other is if we were to delete those objects, those historic objects, you wouldn't be able to recover them, because once they're gone, they're gone. So the other thing you can do to stop us is to enable MFA delete, which basically requires you to enter a multi-factor key anytime you delete something from an S3 container. And that is a really good way of protecting yourself from not just ransomware, but other attacks where really the focus is on damage rather than theft. So how would an attacker go about finding these writable buckets? Really, this is the tough part. This is the enumeration. So we actually created a proof of concept tool for misconfiguration abuse of buckets en masse. It works by leveraging indexing performed by insert search engine here. We can retrieve documents matching certain patterns. For example, we can look for any docx document, for example, or we could look for documents containing the word government classified. You can probably see where I'm going with that. And along the way, we can also enumerate bucket permissions on all of the buckets we find. So I'm going to say this up front: we're not allowed to distribute this tool. We built this proof of concept with the intent of saying, hey, watch this webinar and then you can have this tool at the end. But it's just too dangerous. We can't actually give it to you. So this is called bucketsearch.py, and we've effectively had to lock it away. It's Pandora's box. So it's just going to search for file types that match a specific query string in all buckets it can find, just by interacting with AWS's endpoints. So let's start. It'll get there in the end. Looking for files of type SQL, looking for the term MasterCard. Now, what we've done is we've actually deliberately added a filter in so that this only gives us this one result, because otherwise on this screen I'd be showing you all sorts of data that I couldn't possibly show you. So what we did is we told it to only actually query this one endpoint with this particular query, and this is an intentionally shared data set that contains a bunch of fake MasterCard card numbers and so on. So we can see that we found a sales.sql file, and it's got document snippet, card type, card number, and so on. So let's retrieve that SQL file using wget. We'll download it, and then we'll just see what is in there. And as you can see, they're fake, I assure you, but they are card numbers of various types with all of the data you need to use them. Now, as I say, we've deliberately limited this demonstration so that it only shows you that one response. But using the real application, we recovered literally thousands of these buckets containing exactly this kind of data. So there is, quite accidentally, to be honest, a terrifying amount of information out there. Just repeating that, we're going to look for files of type docx with the query string government, just to show you again just how bad it can be. We're going for shock factor here. I'm going to run that query, and you can see that we found a couple called the government says files. We found a container. I'm actually going to kill this before it finds anything else more scary. But this one file is what we found, but the folder containing this file allows access to 21,904 other files, 15 gigs of data. It is definitely, I can say from having briefly looked before we discovered that we definitely shouldn't be there, there is data there that was not meant to be made public. So that is how easy this stuff is to find. And this was a tool we threw together to perform a demonstration. As I say, it was never intended to be a sort of an attacker's proof of concept tool. We built it we threw it together to build this demonstration, and then we ended up having to take it offline because it was just too dangerous. So yeah, not allowed to share that, sorry. So some tips for defense then, as promised. Searching through your S3 storage using your traditional anti-malware tools isn't going to work, for the exact same reason that traditional ransomware had to be modified in order to work in cloud. Fortunately, cloud native anti-malware does exist. Not only that, but it's free and open source. So just an example, and it is only one, you could go and grab S3 anti-mal. You can download that. It's really, really simple and straightforward to set up, and it uses Lambda functions to query. So every time you make a change inside S3 buckets, that will trigger the Lambda function, and the Lambda function will perform a check on it. It will go off and retrieve from an external bucket the sort of common search terms, the virus signatures effectively, and then it will perform a check on every single file as it's added to your S3 containers. And what's great about this is not only is the actual software free, but you may or may not be familiar, Lambda allows, AWS allow per month 1 million free Lambda executions up to 3.2 million seconds, I think it is, of execution time per month. So if you're not going over your limit, you may well find this is completely free to use using your existing free Lambda execution time. So really, really cool tool there. And as I say, literally every time the S3 object created event occurs, the Lambda function is triggered, performs a scan, it fetches the definitions from that separate external bucket. If the object is compressed, it will be unpacked in order to scan. Object tags metadata will be updated to contain all the scan results, so you'll be able to see what has happened when it was scanned. You can also choose to have it send your scan results out to an SNS topic. And if there are concerns, you can have objects deleted automatically before anything bad happens. So very, very powerful tool. Some other tips and resources, you might want to check out the vendor's own security guidance on storage config. So this is something that they've put thought into. There are best practice guides. There are best practice guides for almost anything you would do within cloud. So these short links will take you to the official vendor guidance. We've also produced a couple of tools. So you can use this tool, the Not So Secure Cloud Service enum tool. You can give it the IAM tokens, the temporary account tokens, from any of your roles that you might have applied to applications, and you can see what services they are allowed to interact with, and you can see whether there's anything that you shouldn't be able to do that you can. You can also download a very, very simple bucket checker script just to check if your storage is resilient to some of the recon techniques that we talked about, and indeed to ransomware. So really quick demo of that using bucket checker, which you can download from our GitHub. It is public, I checked earlier. It wasn't before. And it just runs some basic reconnaissance checks. You give it a keyword. So in this case, we're looking for, I think this was looking for victim. It's found victim private, victim auth, and so on. It's found anything that was externally enumeratable based on some of the commonly used dictionaries that we already know are being used out there in the wild. Finishes up on a QR code because this wouldn't be a webinar with a little bit of blatant advertising. That just directs you towards the cloud course that all of this stuff has come out from. So last thing from me, basically, this is just to reiterate, this is a tiny subsection of the possible attacks looking at storage, and storage is just one service amongst like 200. So we can, of course, this is what we do, help you secure a cloud environment through our interactive hands-on training. We do all of the stuff you've just seen. We do proper labs, basically, of all the exercises we show. So there's no sort of, it's not just me stood in front of a classroom talking at you for days on end. It is lots and lots of hands-on exercises, getting your fingers involved. That sounds weird. And really sort of being able to learn from doing rather than learn from listening. So we cover things like manual and automated container vulnerability investigation. We look at pivoting attacks, where we go from one service to another service, through to another service, extend our privileges, escalate privileges, and gain access to more services. We look at Cognito in a lot more detail. We look at Azure Active Directory. We look at snapshots and some of the damage that you can do there, and tons and tons and tons more. So that's me done, and I'm going to hand back over.
Great, thank you for that, Anthony. I've just got a couple of last things to run through. I think I've just been speaking to Ryan offline, and there's a couple of live questions that have come in, so I'll also hand over the baton to him just after I've gone through the next couple of slides. Sorry, just in conjunction to Anthony's fantastic presentation, if this does take your interest, we've got a couple of upcoming training dates to provide to you. As I mentioned right at the very start, this is both available in a 4-day and a 2-day platform. The UK dates are at the top, as you can see, and the US dates right at the bottom there, which is this is the nearest date, should I say. Also a specific discount code there at the bottom, which is unique to all of you on the call today. Don't worry too much about scribbling all this information. We can send you a copy of the slides just at a later date. On the next couple of slides, I think there's an upcoming webinars, I believe. Of course, of interest, sorry, first. If you enjoyed this webinar, this is a slight, as Anthony mentioned, this is just a flavour, a slight taster of our cloud course. Other courses of interest filtered by sort of nearest availability are as of on the screen now, sorry. And finally, there's some more webinars coming up actually in the next couple of days, and then also moving into February as well. So without any further ado, I'm just going to pass over the reins to Ryan, who's got a couple of questions to ask Anthony, and then we'll wrap up hopefully on time.
Yep, thank you very much, Josh, and yeah, thank you, Anthony, as well for the presentation. It's probably my first time, I think, watching that live, so I learned a lot of stuff off that myself, so I'm sure everyone else did as well. So we have had a couple of questions come in, so I will hand them over to you, Anthony, first. So the first question we've had is, if content security policy in the website allows inline code, does that increase the risk, or is it just not related?
Yeah, definitely. So I'm going to refer to the famous Scott Helm. If you're looking at CSP lockdown, there has been so much written on some of the horrific things that have been done where you're able to inject code in, and yeah, content security policy would definitely help in some of those scenarios. So yeah, if that's an area that is relevant to your role, do go and check out. He's a pretty well known, in the UK at least, pretty well known security researcher. Scott Helm has done some brilliant write-ups on content security policy and some tools to help you do that. That's a whole day in itself, I think, of learning about some of those restrictions and controls. But yes, it's relevant.
Perfect, thank you. And there's another couple. Other than obviously the information you just provided there, are there any automated tools that I can use or anyone else can use to get a better understanding of my cloud security risk?
Yeah, absolutely. So I have to say this because it's my job, but there is no replacement for manual analysis, of course, but at the same time, there's not a lot of point in you paying however much it is to get someone to come in and sort of assess your posture and give you advice when there's a whole bunch of stuff you could have checked yourself using freely available automated tools. So some of the ones I'd look at, there's Scout Suite, is a multi-platform auditing tool. You can give it a auditing account on your cloud environment. So it's AWS, GCP, and Azure. It covers all of them. And it will go off and it will just run a whole bunch of checks. There's a bunch of others out there. There's sort of Azucar for Azure. There's Prowler for AWS, which aligns with the CIS benchmarks. There is, what did I say? Scout Suite. What's the other one? There's another suite. Oh, it's going to escape me. I'll think of it and drop it in the chat in a sec. But yeah, there are lots and lots of usually free and open source auditing tools that you can run, and they will just give you guidance and recommendations very, very quickly and easily. And it is just about getting all of that low-hanging fruit before you end up spending time and money getting the experts in.
Yeah, glad you mentioned the AWS there, because that kind of it leads on to the next question we've had into it. One of the attendees is wondering that in terms of security infrastructure, which is the three, so obviously they've got the AWS, GCP, and Azure. What are they considered? Which is considered probably the most secure in their respective environment?
This is a really dangerous one, isn't it? I should give a balanced response that says it varies depending on what service you're going to use, and you need to assess your own needs. And some will be more secure in some ways, and they all take your security very seriously. And I'm not going to say that I think Azure is the best. From the various different areas that I've reviewed, things like how the metadata API is built, and how secure that is, through things like how you manage your individual service account permissions, Azure pretty much always comes out front. So that's my opinion. That is very much an opinion, just a disclaimer that, but yeah.
That's perfect. And we've got one final question, if that's all right. It's a very quick one. How important is the principle of least privilege? So obviously that's a term or a phrase when it comes to securing services. How important is that?
It is absolutely crucial. So the account we gained access to through that application, those privileges became our privileges. We could do anything that application could do. They should never have been accessible. So we could easily say, well, what does it matter? We could set that app up. It could have access to everything because only that app should ever be able to do stuff, and it should never be abused. The reality is we should always assume that all of our security controls will fail. We should assume that everything will fail open. And so at each level, we should assume the worst, and we should say, well, what if someone does gain access to these permissions? What harm can they do? And what is the point in giving an application or a user more access than they need? Every action, every interaction should always be done using the absolute minimum of privileges that you need in order to complete that action and that action alone. Because you should just, as I say, always assume that something's going to go wrong and someone will gain access to those permissions. By locking them down, you've prevented them from spreading any further.
Great, thank you for that. So that is all the questions we've had in today. As Josh mentioned at the very start as well, we obviously do have a prize draw where you can win a free course, and it is available. All you've got to do is literally speak to one of our pen testers, or make a web inquiry, or you can email that email address at the bottom as well. So again, thank you. I hope you've thoroughly enjoyed it. I know I have personally. I learned a lot of stuff there. So thank you to Anthony and to Josh as well. At the very end, so when this is finished, we do have a very quick survey. I think it's about 4 or 5 questions, so it's not a lot of time. So we would be grateful if you could finish that out. It's just a couple of questions about the prize draw, about the webinar itself, if you're interested in contacting anyone as well. So yeah, thank you again from wherever you are. I really appreciate your time that you give us tonight or this morning, wherever you are. And thank you again. I hope to see you soon whether it's Thursday next week or in February as well when we're running the next ones. Thank you all
very much.